There we go. Now we're cooking. We need... Cool. Boogie woogie, we're a little early. How do you tell if you're alive? Okay, we're live. There's me. Alright, cool. We should be good to go. What's up, Jalapeno? What's up, my brother? Hoping to go through some of this list here. Just a second. I don't know what that is. I'm not gonna look at that right now. Alright. Boy, it's quite the... I mean, there's probably over 50 people here. 3, 6, 9, 12, 14? No. Whatever. 15, 16, something like that. Times 3, 6, 8. 16 times 8. I don't know what that is. A lot. Yeah, so it goes all the way from Leonardo da Vinci to Viktor Grebennikov. Hey, I know that guy. I know John Bedini, Eugene Poklinov a little bit. All these guys are somewhat familiar. I was hoping to get Jason Berbelli in here to go over it with me a little bit. Just give some recognition on Memorial Day for the legends that didn't get their, what do you call it, you know, recognition. It seems to be like, how do I want to say this? Mainstream media is for some reason catching up to these alternative physics, and it's weird to see. It's the weirdest thing ever to see, you know, Hal Puthoff and Sonny White show up on Joe Rogan. It's like, what's going on here, guys? What's the plan? Strange, to say the least. Extremely strange. Especially when Hal Puthoff's just like quantum, 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 quantum. It's not electrodynamic, it's quantum. Meanwhile, it's like, nah, dude, it's electrodynamic. So yeah, it's wild times. What else is new? The Gorgon Stair thing in Sierra Nevada being the, you know, prime suspect is just absolutely insane. To be able to nail it down all the way to that, I mean, you gotta hand it to Ashton Forbes. He's the guy. And the people around him are, badasses. So I say that because I feel like I'm one of them. The amount of physics and science we've uncovered is actually nuts. The edge of the spear, or tip of the spear for real, Vacuum dynamics itself. Creationism. Dang, Jalapeno, I thought we were going to get more people in here. Crazy. I think I've been shadow banned for a couple weeks at least or something, because I'm not getting nearly the interaction I used to. But that's alright. It does not matter. Leonardo da Vinci. Oh, man. What didn't he do? He was a painter, mathematician, geometer. You've seen the human where it's, perfectly scaled or whatever human. Eratosthenes? I don't know what that one is. I don't know. Pythagoras, Plato. I know these two. Pythagorean theorem and triangles and all that. Isaac Newton, Archimedes. I've got the Archimedes screw on my whiteboard for anti-gravity reasons. Benjamin Franklin got polarity wrong, kind of. Well, not kind of, he did, but whatever. Kite in the sky thing probably wasn't real, except for to harvest electricity, not to get actually shocked by lightning, but either way. Irving Langmuir, he's a plasma physicist, came up with the double sheath plasma probe. The Claudius Ptolemy. I feel like I should know that one, but I don't. Oh well. It is what it is. Leonardo Benucci, Yi Zhang, Euclid. I don't know. So many of these folks I don't even know. Galileo. James Clerk Maxwell, we know that guy. Sir William Crookes, I feel like I know him too. But I can't place a pin on what he did. Oliver Heaviside. Kind of screwed this guy over, but so be it. Michael Faraday and Nikola Tesla. That's a good combo right there. Fathers of electromagnetism, basically. Hendrik Casimir, Paul Dirac, Robert Hooke. Oh, Hooke's Law. That's where I know that one from. Heinrich Hertz, Alessandro Volta, Joseph Henry, James Watt, John Fleming, Lev Landau, Wallace Thornhill, let's go, Christian Birkeland, Dr. Pierre-Marie Robitaille, Dr. Edward Dowd, Jr., Montgomery Childs, R.C. Gupta, B.C. Gupta. I don't know what that one is. So be it. David Talbot, another Electric Universe guy. Emmanuel Velikovsky, Halton Arp, Hans Alfvén. All these guys are Electric Universe. At least these 6. Donald E. Scott, he's also Electric Universe guy. Biologist, I believe. Or doctor. Medical doctor, yeah. Don't know who that is. Marcel Vogel. So let's stick to here. Warburg. Ed Leeskelin. Robert Searle. John Searle. Let's go. Thomas Henry Ray. Thomas Townsend Brown. Royal Raymond Rife. Eugene Melov, he's the LENR guy. John Bedini. Viktor Grebennikov. I think I went through these guys. Okay, so that's out of the however many folks there, that's as many as I know. Now, to go through every single one would be, again, another insane undertaking that I don't think anybody has the time for. But out of this list right here, I'd say it's hard to start off anywhere. Well, let me say this. Physics as we know it today is basically stemming from Sir Isaac Newton. It's all Newtonian classical physics, right? But it's never really been how do I want to say this? To go from Newton to Tesla and the ideas gained off of, or the ideas that Nikola Tesla gained were never really understood by me until I looked into like what is electricity itself, and he kind of started in a totally different time period where there was like nothing. I don't even know that much about Nikola Tesla other than it seems like he started from nothing and got pretty much as far as we are today, or farther. But to go from Newton to Tesla is not understood by me, and that seems to be where the gap starts, is from Newton to Tesla, and then from Tesla to quantum. But I would say from there and this is my little thing right now we're going on, is Isaac Newton, Nikola Tesla, Wallace Thornhill. And I say Wallace Thornhill because then he says, Wallace Thornhill goes, it's an electric universe, that's plasma we see out there, and there's really only 3 types of plasma: dark mode, glow mode, and arc mode plasma. And everything in the universe stems from this idea that it's all in a cosmic universal momentum, that everything moves and everything's connected through dark mode plasma or glow mode, arc mode, whatever. It's the interconnectedness of all electrons, protons, fermions, bosons, neutrons, neutrinos, whatever you want to call them. It's an electrical connection that we see from nebula to neutron star to black hole. And I just think that's, the unification of physics is literally like those 3 people study them and you've got, a unified field theory basically for yourself. But, I'm sure there's 20 other folks on this page here that have just as much input. But, like I said, I'm not familiar with everybody. And I'm not technically a physicist, so just because I think I can make a UFO doesn't mean I'm, a real physicist. It's just like the best thing in the world to research is plasma physics and physics as a whole. At least that's where my head goes, because this is like real stuff. This is how the universe works. There's a lot of obfuscation through math and literature, but when you break it down, it's kind of similar. Like when they say, let me pull this paper up. When the Chinese make a paper on anti-gravity bumblebees, it's like, okay, what's going on here for real? Because this stuff is actually understood by academia. They're just not willing to admit it. Like, what is this? The role of non-metricity on neutrino behavior in bumblebee gravity. Long story short, the alterations in oscillation phase caused by the background geometry and the role of lensing effects on the transition probabilities among neutrino flavors complement the analytical approach, numerical evaluation, and oscillation probabilities performed with two flavor scenario. That's not what I wanted to. The gist of it is the possibility that Lorentz symmetry may be spontaneously broken by the way bumblebees fly. So it's another breaking of Lorentz symmetry, which seems to be, the key terminology happening in a lot of these papers coming out and stuff like that. Please, fellas, if you want to come on up. I'm sorry, I didn't realize I had more folks in here. I'm just kind of spouting away, but going off on some of the things, some of the folks on this page listed below. It's the conglomeration of physicists, scientists, inventors from Jason Verbelli. He put this together, and I mean, that's, if there's ever a memorial for physicists, it would be this one. It looks like it's pretty good here. I was just saying how, if you go from Newton to Tesla to Wallace Thornhill, there's a pretty accurate unified field that just emerges, right? There's classical mechanics or classical physics, and then electrodynamics, the Tesla birthing that basically, and it being about, Tesla got as far, in my opinion, as about as far as the public is today, if not even further, because we don't even use longitudinal electrodynamics, but he did. He just called them torsional or something like that. So you go from Nikola Tesla to Wallace Thornhill, who says, yeah, that dynamic is happening throughout the universe too. That's what we've seen these last 100 years since Tesla. It's just we don't admit it. But the sun isn't a gas, it's a plasma. The nebula, the galaxies, the black holes, all those are plasmoids and electric discharges and rotating and all this stuff. That's an interconnected universe. It's not massless pits of dark matter and dark energy that nobody, knows what it is, and you'll absolutely get destroyed getting sucked through a black hole. It's not like that. It's different. It's like a pinch point among the mass of the universe itself, where it all pushes stuff together and you get shot in and out. You get, how do I want to say this? It's like an hourglass. You get shot in and then shot out. Like, if you can imagine a water slide that has the like those funnel water slides, you go woof, swirl down and then in the middle and out. But that's that's the electric universe. And then on the biological side of that, we have Donald E. Scott, who basically breaks it all the way down to microtubules, and that the body is electric and has electrodynamic phenomena that are its processes, from mitochondria to cytoplasm and the nucleus and all that stuff, the ribosomes. They're little electric phenomena themselves. So it's Donald E. Scott. And then I should know Michael Clairage. I should know him. Same with Eric Lerner. I should know these two, but I don't. I don't know the... How many women are on here? Just the one? Good. No. I guess that's it. Just the one. Don't know what she did, but, I'm sure she's there for a reason. Marcel Vogel's an interesting one. I haven't researched him too much, but from what I understand, he's just like a crystal maker who makes Fibonacci ratio crystals that are phase conjugate, meaning they actually, you can't see through the center point of them. they reflect. They have total internal reflection or close to it, where you look down the base of the crystal and you actually see like a mirror image of what is pointing at that face. So you see like a mirror image of your own eyes. It's kind of weird. But that's Marcel Vogel. Another guy, Eugene Malov, he, how do I want to say this? Supported, propagated, advocated for LENR back when Martin Fleischmann and Pons, what's his name? Whatever. Back when they were doing it in the 1980s, 1990s, whatever it was. Maybe even before that. But Eugene Malov advocated for them, and he was from MIT, I believe, and was killed in a bizarre episode of like a neighbor coming and stomping his head in or something. I don't know. Pretty crazy. Probably, you know, a little bit too brutal to go into right now. But, yeah. Super wild, but not uncommon on this list because, again, these are like legends. A lot of them, you know, are silenced, killed, discredited, just because they were trying to say something against the grain, basically. But here's John Bedini. He, I don't know if you would consider him like a black project engineer. Not really. Kind of. In his time, I guess he was kind of like secretive about it, but he, you know, put it all out there for the public to see in a public company or a private company that, you know, was open to the public. It's a little strange how John Bedini and Thomas Bearden and all these guys were really interconnected back then. It's like it's totally different from the way science works today. It's like totally gate-kept and, you know, academized and just non-open to collaboration. But these guys seem to have been ultra collaborative. And I don't see Dan Winter up here, but he's like, I guess, the final boss of all these guys. And could point to a couple other people that would make that tier as well. Lev Landau, I haven't made it through his books, but supposedly, you know, just saying what I've heard, he's got equations for like original manufacturing of anti-gravity, which would be, you know, something else to stumble upon. I tell you what, that's, you know, just typical for the things in this community we stumble upon. But it's just like there's so many names and so many legends to go through. You seemingly keep finding more and more. It's a never-ending Easter egg hunt, basically, but it's the best. Like I've never heard of this guy, Augustin Cauchy. Let's see what he did. Augustin Cauchy. Baron from 1978 or 1789. Whoa, that was way off. 1789 to 1857, French mathematician, engineer, and physicist. He was one of the first to rigorously state and prove the key theorems of calculus, thereby creating real analysis, pioneered the field complex analysis and the study of permutation groups in abstract algebra. Cauchy also contributed to a number of topics in mathematical physics, notably continuum mechanics. Profound mathematician, Cauchy had great influence over his contemporaries and successors. Okay, so founder of calculus? I mean, I don't know. But like I said, there's, you know, a ton of guys to go through, and it's just one of them. I did see Pierre-Marie Robitaille on the Demystify Sci podcast recently. It was interesting. He's talking about black body radiators and how you can't have it unless there is a lattice to maintain that black body. And I was like, that's interesting, because that would mean, like, I know, Joe, you like percolation. It would be like a percolation of the mass itself that is, the black body. Well, I mean, that's kind of obvious, but it's more inherent than that. It's the lattice itself is inherently doing it. And that's, again, nothing new to us, but a very interesting take and something to always keep in mind for black body radiators. Pierre Robitaille, who's another guy here. Edward Dowd, that's Verbelli's guy. I wish Stan Meyer was on here. I could talk about him quite a bit. Irving Langmuir, I want to talk about him a little bit too, because he made the Langmuir probe. He was an American chemist, physicist, and metallurgical engineer. He was awarded the Nobel Prize in Chemistry in 1932 for his work in surface chemistry. Langmuir's most famous publication is the 1919 article, The Arrangement of Electrons in Atoms and Molecules, in which, building on Gilbert and Lewis's cubical atom theory and Walter Kosel's chemical bonding theory, he outlined his concentric theory of atomic structure. Langmuir became embroiled in a priority dispute with Lewis over his work. Langmuir's presentation skills were largely responsible for the popularization of the theory, although credit for the theory itself belongs mostly to Lewis. While at General Electric from 1909 to 1950, Langmuir advanced several fields of physics and chemistry, inventing the gas-filled incandescent lamp and the hydrogen welding technique. Oh, well, how about that? That should be used more, hydrogen welding, because you could do that with, much more simple and safe setups than we have now even. But, or like a hydrogen plasma torch, you wouldn't need anything basically for that. You could just have a water bottle next to your torch setup that's an electrolyzer and constantly make fuel for the plasma torch instead of having to buy these massive bottles of, acetylene or whatever. Yeah. Lots of different ways to do stuff. There's also Oliver Heaviside. I'd like to talk about him a little bit, and if anybody else wants to talk about anybody, feel free to, jump on up. But Oliver Heaviside's interesting because he took James Clerk Maxwell's equations and the differential equations of James Clerk Maxwell and brought them down into electrodynamics as we know them today for the most part. It's the telegrapher's equations, yeah. And where is it? Propose the existence of what is known as the Kennelly heaven. No. First. No. Heaviside did much to develop and advocate vector methods and vector calculus, but he forgot about scalars. And that's where James Clerk Maxwell's equations fully interpret scalars. But where that's important is electrodynamics are everything, so it's kind of hard to nail it down. But in the context of Oliver Heaviside and scalar electrodynamics, scalar and vector are two sides of the same coin, basically. The thing that is an atom has a scalar and vector electrodynamic potential. Every atom, every phase transition, everything we measure has that. The vector potential is simply the pointing vector. It's where this thing is going, its velocity, momentum, its transverse wave, the sinusoidal wave that we measure in Fourier calculus to send signals and transmit and move and do everything. That's vector calculus. Scalar calculus is a little bit different in that it takes that vector potential as a source thing, and you can multiply that and move it around and use that potential as an engineering thing that interacts with some of the more fundamental physics at play, being gravity, the bonding mechanism, and the momentum transfer mechanism. That's the scalar physics that have been gatekept. So the point of it is, if we could transfer momentum from being this thing that is a purely kinetic thing where the energy is always lost in this closed system, if we can transfer the momentum from somewhere else, whether it be a vacuum or a coupling from atoms right next to you, it's somewhere else that transfers the energy that you use. Now, that's a little bit weird to think about, but it's like the balloon. It doesn't make way for where it goes. It just kind of floats with the wind, right? The wind is always present no matter where you are in the universe. It's just the amplitude doesn't necessarily match the mass. So it's a little weird to think about, but the cosmic microwave background is responsible for a lot of these advanced scalar electrodynamics. And they measure that as a Planck wavelength and time to make up momentum itself. But yeah, it was a little bit of a rant. What's up, Fletcher?
I'm not sure I come up here and give you some company. I heard something you said, trying to get, trying to store energy out of that vast amount of kinetic energy that's out there. I was thinking an oscillator,
Yeah.
like use some sort of oscillator to store charge, right? Maybe.
Yeah, it's like, what is the, mechanism of oscillation itself? Some kind of mirror effect of the thing, right? So it's like, where does that oscillation originate from and everything? It's got to be.
Well, I think it's like I see it as like a timing issue, right? Like, if there's a certain wave form in this, vast sea of kinetic energy, or this hypothetical one that we're talking about, if there's like, let's say it has a waveform to it, right? And you can tap in, and basically just like you would stack charge, if you were like pumping electricity into an antenna or some kind of a electrical circuit of any kind, right?
Mm-hmm.
If you add AC power at the right time, you can stack these charges. So I picture it as doing that in like reverse, basically. So you end up stacking the charges off the waveform of this kinetic field into some sort of either battery or directly to power things, I guess. Capacitor, maybe. Put it into a capacitor.
Yeah, there's
It basically is that oscillator thing. I think is basically a capacitor, right?
Yeah, so an RLC circuit is a resistive inductance and capacitance circuit. So there's everything measured in the universe has that, a resistance, inductance, and capacitance. It has those three properties inherently. Whether you're a hydrogen atom or a fucking plutonium molecule, you know what I mean? There's something to this fine structure constant / uncertainty principle that literally gives energy. I don't know how else to describe it, but that's what physics describes it. It's the quantum vacuum fluctuations. It's a oscillator, an RLC circuit, basically. Um, yeah, but the energy itself is always oscillating. So it's like, okay, we have copper. Copper is a giver of electrons. Why does it do that? It's like that itself is a break in the second law of thermodynamics, but we just don't think of it like that. The ability of copper to just freely, not freely, but very close to freely give away electrons is damn near breaking the second law, because again, where do these electrons constantly come from? You know, that's really the heart of the question, is what is energy? It's everything. It's power. It's life, movement. Just depends on what you're trying to make. The cool thing is the scalar geometries, the longitudinal geometry, apparently is literally the resonant connection of the universe itself. So you can just tune the system that you're making, whether it be a Stargate or some kind of like crucible for fusion. You can tune it to the geometry of Earth or wherever just by literally doing longitudinal geometry. Supposedly that's how the superconductive stargates work, is literally longitudinal geometry. Which I guess that's a little bit, more complicated than just doing, Pythagorean theorems a couple times over. But because everything, again, in the universe is constantly in momentum and moving. But either way, just that fact, it's like, okay, you could learn this in 9th grade, totally. If you had really good teachers and stuff. It's like, damn. Humanity's really been held back. But yeah, I guess we can keep going in memoriam. Is there anybody you see on this list there, Fletcher?
I really don't even know what you're talking about as far as what the list is.
Oh, just in the comments here, I posted a link to a picture
So I don't
Jason
see any
had done.
comments at all.
What's that?
I don't see any comments. My comments box is broken. But I can look up his. Did he just post it recently?
Yeah, he posted it sometime today.
Okay, I'll go look at it and let you know. Hold on.
Van de Graaff and James Wimhurst. I thought a Van de Graaff Wimhurst machine was the machine. Am I tripping right now? I might. Hold up. Hold up. Van de Graaff. Oh boy. Wimhurst. Van de Graaff generator. What's the difference between that and a Wimhurst machine? I thought they were like the same thing. Or is a Wimhurst... Wait a minute. I think a Wimhurst machine's like rotational, right? Electrostatic generator. Yeah. Yeah. Whereas the Van de Graaff machine is electrostatic. Something like that. Electrostatic generator. Yep. Moving belt to accumulate charge on the hollow metal globe on top. Yep. Something like that anyways. The advancement of electrical generation hasn't really gone that far when you go from like steam powered stuff to where we are today. It's a lot of times the same thing. Like they just use steam to drive, which is not a bad thing. It could be, much more efficient, but the technology to make the steam really hasn't changed much. It's heated elements and baths of water pushing turbines for the most part. But if we pumped turbines, that'd be a whole different thing. Pulse pump with steam, even that would be way more efficient. And I'm sure there's all kinds of mechanisms that do that in today's world, but I'm not aware of them. And until I see like actual changes start happening to benefit people and not just be planned to be obsolete, planned obsolescence, until that ends, I would make fun of mainstream constantly. They don't deserve any glory as long as planned obsolescence is alive and around, in my opinion. But Viktor Grebenikov. What's crazy about that guy, to me, is I had the realization that bees were anti-gravity sometime either at the end of last year or early this year. And come to find out, this guy, Viktor Grebenikov, basically did all that research back in the day. Like, his whole thing was that beetle skeletons, he was supposedly literally flying around on beetle skeletons. So, I mean, that's kind of like, well, I'll be damned, right? It doesn't get more ironic than that. So, Russian, too. A lot of Russian physicists apparently were unchained in their research. They seemingly went pretty far while America was stagnated in the Cold War era. Viktor Grebenikov.
So I just looked through the list, and I don't know, man. Like I told Nathaniel the other day, I think I'm about to fall down like some kind of hermetic rabbit hole here. So the Greeks that are in there, and Da Vinci is on the list too. I'm surprised that he put Da Vinci first on the list, because I've been learning some stuff about him that's very interesting.
Oh, yeah?
Yeah, some this dude. I'll find the video, but this dude, he found, he got some kind of download or something. And I'll send it to you since the chat is broken. But yeah, he had a realization about some geometry. I sent this to Hollow actually too. I didn't know if everybody would really appreciate this or not, but here I'll send it to you as well. I didn't want to blow up one of the group chats with it, But he found some interesting sacred geometry relating to the pyramids in Da Vinci's artwork. And he goes pretty deep on it. The geometry starts about 15 minutes in if you want to skip ahead, but I enjoyed kind of the whole thing. I think it all was pretty coherent.
Yeah, apparently Da Vinci had flying machines too, right? Little helicopters or gliders, I think it was. Some kind of like spinning, or maybe it wasn't a spinning thing. It was just. Oh,
He seemed to have a lot of ancient knowledge, a
yeah.
lot of ancient sacred knowledge. Like, how did he get all of it? Like, he was either really tapped into some kind of, other kind of consciousness field or something where he was, I don't know where he got all this information, but a lot of it just lines up too well with all this historical stuff that we're talking about, from technology, religion, all the stuff, and he brings it all together. Pretty interesting.
Yeah. It's extremely interesting. It's wasn't he the originator of the Fibonacci code? Fibonacci sequence? Or is that based on another guy named Fibonacci.
I think he used it. Um, if I remember correctly, I remember for some reason seeing it in his artwork, but that could have just been his knowledge of sacred geometry. Um, because after, like, if you watch that video, you'll understand what I'm saying. Where, um, yeah, you can post it in the chat or something if you want, but my chat bubble's not working. Um, but
Mm.
you know, he has too much knowledge of sacred geometry coded into his paintings for him to not understand basically all of this shit.
It's kind of unfair how these guys got to be Renaissance men and we're just, slaves to the system these days. But, I mean, yeah, he made substantial discoveries in anatomy, civil engineering, hydrodynamics, geology, optics, and tribology, the science of understanding friction. Tribology. But he did not publish his findings, and they had little to no direct influence on the subsequent science.
I wonder if he published them all in the basement of the Vatican or something, you know?
Yeah. Willingly or not. Yeah, that's another thing. Is the Vatican's probably got, who knows how many thousands of years worth of information down there. Literally dating back from thousands of years. Like, they probably have books that were created at the time of Christ or something, you know what I mean? And just nobody knows about it. Or a select few do. I'd love to get their physics textbooks from 2,000 years ago. Like, were they thinking it was all gods in the sky, like, ancient tribes or whatever? Or were they more attuned to, like, the electric universe dynamic where they were seeing plasma discharges and thunderbolts and stuff like that? Who knows? Secrets.
I mean, apparently he's got like the full um, geometry of the pyramids and function
Da Vinci.
encoded, yeah, encoded into his paintings.
Really? That'd be
Completely
something.
mathematically correct too, and it all just uses sacred geometry. Pretty interesting.
That is interesting. That's really interesting. The idea. I didn't even think of sacred geometry as anything. I didn't know it was a real thing. I didn't know anything about it. I thought maybe it was. Like 2 years ago, if you had told me the word sacred geometry, I would have been like, what is that? Like some kind of class you take? What? I have no idea. But I heard it like 3 different times, and then I realized that um, that idea of geometry and symmetry itself is just the array, the lattice, the crystal structure, the way to do things. It's not
Yeah, the way
necessarily.
to act.
Yeah, it's just
I,
the
I
thing.
woke up. Yeah, same with you. You know, I'm on the same book page as you, where like I didn't really understand like what does it mean, like, and you can see it on someone's face when you try and use the word sacred geometry, and they're like, what? But
Hmm.
it happened to me too. I had a really very interesting experience one night, and then the next morning I woke up and Roy was hosting a space, and nobody was up there talking, and I was like, and he was like, "Come on, don't be shy. Someone come up. I know someone down there has something to say." And I was like, "Okay." So I went up and I told him the story. And the first thing he said, "Sounds like you stumbled upon some sacred geometry." It's like,
Hmm.
what happened, huh? Um, yeah, man. And Hollow had an interesting experience one time in space where he was trying to explain something that he had found in his research, and um, some voice popped into his speaker and said, "It's not time to reveal that yet." He like got too close to it somehow and said it was pretty weird.
Mm.
Said he went back and listened to the recording and it was not on the recording, but it came through his speaker and said, "Don't. It's not time yet. Keep that under a lid."
It's you take the idea of a Josephson junction, right? And then you add a little bit of sacred geometry to that. You could get an array of Josephson junctions and basically create a Stargate on a microscopic scale. I don't see why you couldn't apply that to a macro. Um,
Well, that's one of the most important parts if you're going to try and weld up a thunderstorm generator yourself. If you're going to try and build one. Um, One of the most important parts and hardest parts to get right is that the specific angle where it goes from one of the tubes into one of the ball, like into the balls, where it goes from the tube into the ball, that neck angle is super, super important to get it to work.
mm.
And it's just, I can't remember what the angle is, but like that is really important somehow.
Yeah, the Dan Winter says it's like 51-degree angle at the tip of the pyramid, I believe. Or maybe, yeah, tip of the pyramid in Giza. And, 68 or whatever, 68.5% or degree angle on the side. The pyramid itself is just a diode. That's the crazy thing, is like these diodes are electrical components we use every day to gate one-way flows, to literally force current in a one direction. If we just expand that to the pyramid on the planet, on the surface, oh my god, it's a diode. The effect isn't in our spectrum of light that we see, but we can measure these things with like radio oh my god, grid dip oscillators, these radio measurement tools that measure the frequency of specific antennas and stuff like that. You can measure antennas or pyramids as being charge flowing diodes. And supposedly, that's been done already. But again, it's all just technology. And the cool thing is, like, even if human inventions don't work, they're still human inventions. And it's something that popped out naturally into the universe. So you can learn something from everything. And once you see the electrical dynamic in between all circumstances, it's like, oh my god, you know, the progression of everything just keeps moving on and on and on, and it's a beautiful thing to witness. The fractality of it all, I guess. Yeah. Um, Another thing physics doesn't take into account is fractal phase conjugation, but that's another thing.
Yeah, scale invariance.
Scale invariance, yeah, that's the thing that they supposedly can't find between the quantum and the macro, but it's like right in everybody's face as being some kind of fractality and some kind of plasma effect, where plasma having the ability to self-coagulate and self-cohere its own body basically in a vacuum. You take that, and then you take the fractality we see of being, you know, even stars, if we just think of them as circles everywhere in the universe, okay, why is it always circles? You know what I mean? Or if they're always squares, why is it always squares? Well, it's not always that, but there is a pattern that we see, you know, throughout time and space. And, I'm in Dan Winter's boat thinking that is phi, the golden ratio and all that. But how to use that in an electrodynamic sense, it's kind of beyond me at the moment. I think it's something to do again with this um, scale variant, scalar geometry, and electrodynamics. But that's a deeper
Yeah,
rabbit
'cause it
hole.
all kind of starts to come together when you get down to Planck scale type stuff, whether it's a semiconductor or a graphene or like um, It's like all these the material world starts to fall apart and everything, and then all your when your scale becomes like more invariant, all of a sudden you like are there's way more energy and but like also way less material to work with. So I don't know.
Yeah. The idea that you can just twist a part of the vacuum, basically, and end up with a pair production of something: hydrogen, helium, argon, neon, whatever it is. Um, it's it's kind of weird to think about because Bob Greenier says that these fractal toroidal moments are creationism. It's the thing that creates and transmutes and dissolves matter. So in order for something to dissolve, it's also got to percolate. And it's weird to think that that can just spontaneously happen, but it's not quite spontaneous, is it? If there's an array of everything else in the universe outside of you, well, that's pushing and making an impact. Whether we just don't measure it, but that's what's going on. Is you're not alone. If there's one thing we can say about one particle in the universe, it's that it's not alone, right? So there's always an interaction going on, and the vacuum is the force. Like this one, the problem is really right that we think classical mechanics and quantum physics say that all objects in a vacuum fall at the same velocity regardless of inertia, velocity, or mass, right? Well, that's just not true. We've discovered that multiple times. There's a Casimir effect at play where there's, standing waves in every piece of matter, and the vacuum is supposedly responsible for these standing waves. So what does that mean? It means that there's pressure constantly on the thing moving, and it's much easier to think of like, again, you're underneath an ocean, or I haven't said this yet, but you're underneath an ocean, and you can imagine that Titan submarine that blew up a while back. Everything blew up, right? But it wasn't a blow up, it was an implosion because all that water immediately filled that cavity, right? That's exactly what goes on in space. Things are being filled immediately by the vacuum. So you're always getting a pushback effect. There's always, some form of momentum going on if you have a thing in the vacuum as, an atom, an atomic structure. Um, but that's the gist of
Yeah,
it,
did you see
right?
that picture of that cow in that tornado recently?
What? A cow in a tornado?
Well, it was in the tornado, and while it was in the tornado, he got impaled with a 2x4. So
Oh,
this thing was just walking around with this 2x4 sticking out of it. The cow looked totally fine, but it was just totally embedded right through, no blood or nothing. It was just like a 2x4 coming out of the cow. It was wild.
yeah, I did see that. That's that's why you don't go outside in storms, right? Crazy. Just a cow tank and a board to the side. Freaking cows are crazy animals. They just kind of let life happen to them. I don't know. I feel like you could literally put a lighter in the face of a cow and they probably wouldn't do much. I don't know. I've
Yeah,
never.
when you're talking to them, you basically have to yell at them to get through to them.
I've spent time on farms, but not enough time around cows. The chickens were more friendly to me. But yeah, I don't know. The one thing that is insane to see is again mainstream is kind of pushing the idea there's an exotic physics behind closed doors and they have to push disclosure in order for it to come out. But on the opposite side of that is China, literally doing it in the public, in everybody's face, and whether they're bluffing or not, they're calling other people on their bluff, right? They're calling the United States on our technology bluff, right? So I don't know. It feels like there's another space race going on, sort of. It's interesting. Very interesting.
Yeah, I think instead of a space race in outer space, it's a space race in inner space.
Mm. It's a good way to put it. It's a really good way to put it. Yeah. The one guy on here on X who talks about UFO technology quite often and physics of it said that there's for sure Department of Defense bases throughout the solar system. And that's just so crazy to think about, but also like obvious in my mind at this point. Like, of course they have those things. Of course there's bases, throughout the solar system. They had to have if, like I believe on the technology and physics side, if I believe what I believe, that they figured out anti-gravity quite a while back, then of course they'd have that done by now. And strange times. I saw a video of some guy talking to Trump the other day about energy, and he mentioned MIT to Trump and gave him a nod and stuff because of John Trump, Donald's uncle, who was a MIT professor, and you guys know the story. It's just strange, man. Really fucking strange. It's like the plot is beyond fiction, I guess. I don't know. Yeah. Anyways, I guess the best thing to do is, again, find a free energy device for yourself and make it, because you get a little bit of free energy, and oh my god, you've got the most profitable money tree on the planet, and on any planet, literally. So that's the goal. You can kind of, if I could figure out transistors in a more profound way and figure out how to code this Arduino, I probably have something already, but it's a process. And we're going to make it anyways. So if you guys know anybody that codes, tell them to hit me up. I need some Arduino help. But yeah, I don't know. Hopefully it was a good memorial of some giants who went beyond Einstein. The main thesis is that there's, I like to call it an electric universe, whatever. There's a unified field out there. It goes by many names. Lots of engineering and work to be done. And there's a lot of hope to be had. And don't look to Jeremy Cowbell or Joe Rogan for disclosure, because the real disclosure is in physics books, or even non-physics books. Like I found this ether technology book by Rho Sigma. Totally real. Crazy. It's not a physics textbook. It's more like a popular science, like non-fiction-y type thing, but it's real, So there's I don't know. The problem is just getting more people to wake up to it, right? Getting people to pay for the free energy, to pay the attention to it, at least. But not in the Jew Elizondo type view, not the fake disclosure type way, in the I want to build this myself type way. So yeah, I should say I do have a Fire, and I've also built, as of today, a sound seat. Basically, you sit in this thing, and it's got 4 speakers, 2 on each side of you. That you can play any music. I was playing some binaural beats through it, and it was just crazy, man. I had a headache when I sat in this thing. Not even joking you, was gone when I was done with it, and it was like maybe 5 minutes of binaural beats sitting in this chair. Crazy, man. I've literally never had anything be that effective. Like, I've had anesthesia for my wisdom teeth, and that, I feel like, took longer than this headache cure. It's crazy. I don't know. How have you been, Fletcher? I feel like I've been pretty sick, and not in like a physical way, but just like headaches constantly in the last week. I kind of attributed that to the sun, but maybe that's too far in the astrology
Oh
realm.
yeah, for sure. No, I've been seeing all kinds of crazy stuff happen from this sun. So yeah, man, I would not doubt it. 1 second. Got me even a little bit almost. Got me all angry one day.
Yeah,
Very beginning, it was all starting.
it's just like no matter what I do this past week and a half, it'll be 3 days of headache and then half a day of not, and then a day of not, and then 2 more days of headache, and it's just I don't know. It's getting annoying. But the sound seat is you know, pretty cool, pretty cool. I'll have to post a picture of it here pretty soon when it's not just outside of my trailer house in the grass and can be shown off a little bit more. It's you know, it's frustrating to live in a little box, but we're making moves, we're getting places anyways. I appreciate you guys for coming here. Like I said, I was hoping to have Jason Verbelli go through some of these a little bit more, as he's obviously much more familiar with the subject matter and topics. But it's fun anyways. Yes, sir. Alrighty. I think I'm going to close her down. Fletcher, you appreciate you coming up, brother.
Yeah, thanks for doing something cool here.
Yeah. I mean, there's, again, you guys are probably all familiar, so I'm kind of preaching to the choir, but it's always fun to go through some of these guys. Like, um, the Oliver Heaviside, I thought I knew more of how exactly he screwed up Maxwell's equations, but I'm going to have to go back and refamiliarize myself with that because it's been a while, and I don't want to get completely caught off guard on some of these guys like I was tonight. Like I thought I had a better understanding on some of these folks, but it looks like I don't know. I'm kind of still stuck in the Stanley Meyer type viewpoint because he kind of weaves his way through his inventions into everything. But anyways, that's also been another project of mine recently. Is this Stanley Meyer water fuel cell here? I'm gonna show this on my camera. I got some electrodes wired up today in the block I made. Pretty simple. It's just 6 stainless steel wires and 3 stainless steel tubes and 3 stainless steel rods. So nothing major, and it looks extremely ghetto, but it puts out some HHO anyways. And once I figure out this Arduino, it's going to be even better because then we can do some pulsed electrolysis, which will be so much more efficient. It'll be incredible. I mean, the numbers from straight DC electrolysis to pulsed electrolysis are literally like 70% hydrogen to 99% hydrogen. Just because, when you pulse it, you don't have to move the whole water molecule. You can just move the hydrogen, basically. And the pulse method is extremely relevant to basically everything, right? You literally have a pulse. You don't have a, your blood isn't technically a direct current. It's more like a pulsation of your fascia and tissue and all that. So, as is your heart, brain, all that stuff. Anyways, I'm going to get off on a rant if I don't end it now. So, again, appreciate you fellas. You guys mean the world. Yeah, you're the best.